I'm not sure how I should start this, so I'm just going to get started. Over the last 1 or 2 months, I've been doing quite a bit of statistical data with Blackjack. This is a graph showing the general odds for being able to take a hit and not go bust. Now, I say general because this does not take into account the cards actually left in the deck. And it also does not take into account hands that have aces. For example, if you have a hand of 16 that is an ace and a 5, the odds of you going bust is different if you have a 10 and a 6, because that ace can turn into a 1. Here I've attempted to calculate the relative frequency of any starting hand in Blackjack. I did this based off of all 2-card combinations that are possible with a deck of cards. The amount of 2-card combinations in a deck are 1,326. Now, with my calculations, they add up to 1,324. I'm off by a small margin, and I don't know why. Even though there is this small discrepancy, I know for a fact that these values are correct. This is because I lifted these values from this website, who's authored by someone with a PhD, and I tried to emulate his same method for the rest of the values. Here's what the relative frequency graph looks like for this data. I did think this looked a bit odd. As a way to double check this, we can test this out with a real deck of cards and dealing to ourselves and shuffling, etc. That's where this data set comes in. This is based off of 601 hands with shuffling and cutting the deck in between. Up at the top here, we have some basic summary stats. SD is just standard deviation. You have the average, median, mode, and z-scores. Z-scores are for calculating outliers. So this is a bell-shaped distribution. So we have data that's more probable to occur than others. If that data is below a certain threshold, we can call it an outlier. This can be done with a couple of methods, but I have used z-scores here and have chosen to use a z-score of 2. A z-score represents how many standard deviations away you are from the mean. So with a z-score of 2, that means that this data is 2 standard deviations away from the mean. Here's the relative frequency graph of the data I collected myself. You can see it looks a bit different, but it's generally the same. The biggest difference is with the relative frequency of 4 and 20. A question that might come up with this data set is, how could I compensate for bad shuffling? The answer is with sheer quantity of data. 601 games, I'll call it, is not an insignificant data set. With a data set that large, it should conform to the overall probable relative frequency. For example, flipping a coin. If you flip it enough times, the outcome of heads versus tails eventually comes out to 50-50. That is a mathematical certainty. Alright, yep, that's it.